a POC, as in a non-usable product that proves something, is a nothing burger, I think. Most of the time. Got to crack the nut. Even if you deliver something on a small fraction of their data, on a small fraction of their business, yes, there's no escaping the chain of reasoning that needs to flow from the problem back to the solution.
Welcome to the Spatialedge Industry Insights show. So I'm your host, Pierre, and today with me I have Dr. Jonas Stray. Jonas is currently the lead data scientist at Pepkor, and Pepkor is a big retailer within South Africa, merchandising and clothing, etc., over all of Africa, with over 5,000 stores and over 64 billion rand in annual revenue. So Jonas, tell me a little bit about yourself. Give me the backstory of kind of where you came from and then how you ended up becoming the lead data scientist at Pepkor.
All right, thanks, Pierre. I was born in Sweden in that is 1976. That's many years ago now. I had my first half of the career in academia. I did my PhD in South Africa, and that started around 2008. I did that in the sugarcane industry, looking at optimizing the order in which you harvest the fields for bigger sugarcane estates. I then went back for a short stint to Sweden. During that time, I got a job at UCT, so we moved back with my young family to South Africa in 2012, in December. I spent about 4 years at UCT teaching statistics, mathematics, and optimization methods, queuing theory, sort of OR-related topics, most of them. I then got the opportunity to start working in industry again, which I had done previously in my life in Sweden. I'd worked in quality management and product development or process development. But now I went into the retail industry for the first time, which was in 2017 in January, as a senior data scientist.
Out of interest, how? So you've got then quite a bit of academia experience, quite a bit of experience lecturing. How does that differ from being in industry? So how does being a lecturer in statistics and mathematics differ from actually going in and doing data science?
I mean, a major difference is that your knowledge has a different outlet. In academia, your knowledge, on the one hand, has the outlet of teaching it to other people. Mm-hmm. Mm-hmm. And on the other hand, you have to produce research. So your knowledge is also applied in problem solving, in a research-like setting, where the objective is to publish a paper, to put it very bluntly. In industry, as a data scientist, your knowledge has a different outlet, and it's part of a different kind of process. It's very much more value-focused. It's much more, let's say, method agnostic. The important thing is not which method you're investigating. The important part is how you meet the client's need by formulating their problem in the right way. So I think that's more of a skill than knowledge to begin with, or a drive to do it that way. That if you don't have that passion, then it's going to be a little difficult to make a transition like that.
Out of interest, when you say it's like a skill, that reminds me that it's not something that you can easily pick up while studying or while doing other roles. Is that something you can only kind of learn, or at least I think it's something you can only kind of learn when you're in the industry trying to figure things out?
I think you can compare it to, let's say you're a good runner, a very fast sprint distance runner. I think at some point you would have been a person that enjoyed the speed and enjoyed that part, which is what drove you to develop the skill to run faster. There's a bit of talent involved for obvious reasons, but there's that drive underneath that takes you to where you develop the right skills for this area. If you are a very analytical person and your primary drive is to understand everything and you find enjoyment out of that, it's not a negative part of being a data scientist. It's something that you need, but it's not perhaps the drive you need in order to develop the skills that are the most scarce among data scientists, which is being the person who has as an absolute must in them or inside of them to bridge the gap between the client's needs and what you can do for them, to identify the right problem in the right way and to conceptualize the right solution for that. Those are the most difficult parts of data science, I believe. Speaking very generally, I mean, there's modeling techniques that are incredibly complicated and difficult to employ and deploy. But in general, for most data scientists, it's about framing the problem properly, sitting with the client and not just doing exactly what they tell you to do, but thinking beyond that, asking more questions than you think you need. Building a picture for yourself that makes sense of what the client needs, understanding it, truly understanding it, and taking that further into a solution that will work. And you will almost know before you start that this is going to work. If you thought all of it through properly, then you will have that feeling that this is actually going to solve that problem better than they ever imagined.
Yes, that's quite interesting. So I almost want to summarize that in some sense. So as data scientists, you develop the technical capabilities to develop models, to build out different components, you understand the stats, you've done the math, you've got the skills, you've got the background, but now it's around understanding, or the scarce skills that you're talking about understanding, well, there's a need that the customer has. I've got all these tools in my kit, and now I need to apply it to solve their problems so that we can build a model that improves some metric or changes something specific. And the whole idea is that the better you understand the problem, the better you can apply your tools to then solve the problem. That's basically what it comes down to. But like you said, not just what they're saying, because they have a way, I guess people always have a way of expressing themselves and, oh, I'm really struggling with my demand forecasting, whatever it may be, getting my pipeline to go run, or whatever the case may be. But is it just that? Is there something around it? What about it? Getting into the details and to really understand, but what do they mean with that? If the guy tells you, I'm struggling, what is it exactly? No, I agree with that. That makes sense.
Yeah, I think that meeting between the data scientist and the client is an ongoing process, particularly during the first weeks of the project, where I, as a data scientist, develop a better understanding of how my client is doing the thing that they need help with. I develop a better understanding of their planning process. I develop a better understanding of their supply chain. I develop, an understanding of what they do. They, on the other hand, will begin to understand what I'm about to give them. So I'll explain in bits that I think this portion of your problem is a machine learning problem or a predictive modeling problem. Whereas this other part, which we haven't discussed so much, that might be an optimization problem. The third part might be their BI needs that should flow out of the project naturally as well. So when we solve the bigger problem for them, or the more important problem, so to speak, we also think of their other needs. And if you really want to scale or accelerate the value of your efforts, as a data scientist, you need to step back nearly all the time and think about the project, and not just go in and act like a quick fix hero and build them a cool model and hand it over and run away. It's important to enter that relationship with a lot of respect and care, And that's where that old drive comes in. I mean, I never feel better than when I know I'm going to give someone something that will benefit them. That's when I'm happiest.
You mentioned something very interesting then, that's you feel happiest when you're able to effectively solve the client's problem and needs. So I always want to say that you must be satisfied or quite satisfied with some of the solutions that you guys have developed so far for the different clients within the group, with some of the impact that some of the systems have been made.
Yeah, and I mean, that's where you realize that when you've tried on your own as a data scientist to build something from start to finish, and you know that it takes much longer than you'd like it to take to finish that thing and to get it automated and to get it into monitoring and to get it into a place where you can actually let it go and live on its own, you realize how much of a team effort this thing is. So that's kind of the space I'm in now, to work with my team to find the way we need to behave as a team, or the rules we need for our team in order to maximize the pleasure of being able to deliver nice solutions as fast as possible, with as high quality as possible, and with as much fun as possible. You know, laughing about it and releasing that creativity through a positive attitude. And that's always been, since the day I got my first team, that has been my goal, to create a space where people are relaxed and where people are happy and where they feel safe.
That's so important.
And where they have support and a very low level of within team competition. So you're not competing too much against your peers. A little bit of competition is always cool, but it can't be an environment where you're under pressure if we require people to think creatively at all times.
That's an important point as well. So firstly, 100% agree. Like, if people are in a safe environment, if they're happy, it's actually not counterintuitive at all. Like, if you're happy, if you're in a safe environment, you're going to be communicating better, you're going to be performing better, you're going to be wanting to do stuff, you're going to be putting in a lot of effort, even though there might be specific, I guess, milestones and deadlines you want to hit. So what? You like having fun because you know you want to solve that problem and get it delivered to the user. And then another thing that you mentioned there, which is quite cool and obviously interesting, is not having like competition, in the sense that people wanting to beat each other down or beat each other in the way that you'll start sabotaging each other instead of helping and being collaborative.
Once it goes overboard and you start having negative effects of the competition, you got to take a step back and look at what's going on.
100%. And so tell me, so I guess you mentioned there as well, you kind of from the start, when you got a team or putting a team together, that you wanted this to create this kind of environment. Now you transitioned from the academia into the retail area, and you mentioned you didn't have actually any retail experience, or did you have retail experience at that point when you transitioned?
No. And
how did you kind of, I guess, start to survive within that area?
So I immediately went to meet with people and talk to them about their problems. So that I asked them, what problems do you have in your space that you think data could help you with? Just a very open question. And everyone was very open to talk. Everyone was, so I mean, Pepkor is a very big group and there's a lot of companies you can go and talk to. And anywhere I went, there's always this interested person to be found with whom you can have a really good conversation. And it's in a big group and for a big business, there's always a lot of money involved in the solution of the problem. So anything you touch that has an impact on the critical path of retail, which is just another name for its main process of moving the stock from supplier to store and into the hands of the customer. I think anywhere you touch that space and you can have an impact, it's going to be worth a lot of money. We found one pretty quickly that was a very important part of the process. So go out there. I mean, if I'm speaking to the data scientists out there, don't be afraid to spend a day with your clients, not having your notebook with you even. Just talk to them, just listen. Try to understand what their daily work is like and what the big decisions are that they have to make, and keep that until your natural instinct, by natural instinct, your brain will start to put these things together and think about, wow, maybe here data could help, or here a model could help, or here optimization model could help, software could help. So it happens naturally, I think.
Would you classify yourself as more of an introvert or more of an extrovert?
I'm just a tiny bit more introverted than extroverted, but yeah, I like alone time to recover. I don't mind having to perform amongst people.
You mean like present?
Present. I don't have a problem with that. I don't get too much energy out of it.
Yeah, I've seen you been, actually on that note, I've seen you been very effective in meetings and very effective with clients, very effective with explaining very difficult concepts. So 100%, I've seen you perform like really good. But yeah, I hear what you're saying. So it's not like it energizes you and you want to do it all the time.
Yeah, it doesn't give me, so after that, I would not want to go out and hang out with people and have beers and, whatever. I'd rather go home and chill.
Okay, that makes total sense. The reason I ask this question is, when you say, for example, going out and talking to a lot of the customers inside the organization, I feel like for the normal kind of person who would do data science and who would do statistics, mathematics, computer science, is definitely not an extrovert. It's definitely more of an introverted person, because I mean, the kind of work you do is you kind of, at least when you're studying up until the point where you get into the workforce, you're basically working with systems, and you're working with tools and things and data, and not people as such. So going out and talking to people could be a very daunting task for a lot of people, which is why I think it's difficult. But I mean, even with being an introvert, it's something, like you mentioned, it's something you have to do if you want to understand your customer well, if you want to understand the context, also you can create the right solution.
Yeah, I completely hear you. I think a lot of data scientists are, by their very nature, introverted, and they need their alone time. They need that to regenerate. I do, however, believe that there are a lot of things that you can learn almost mechanistically, bring with you when you go out, that are important to preserve you in that context. So what I mean is, if you go and see a client for the first time, what you do not want to do is to bring this image of yourself that you're the problem solver and you're going to help them and you're their messiah of sorts. Rather go there with the attitude that you probably know better than them. A lot of, and I mean, even if you're a really good data scientist and you're very intelligent, you have a high IQ and all that, and you're very good at programming and math and whatnot, the executives out there in a serious business, those are all very, very intelligent people. And it's actually very important to be humble. It preserves you as well as the relationship with your client. You have to learn how to admit that you don't know, particularly in the beginning of the conversation. One huge mistake that is very often made is you go in there with the feeling that you have to give them something nearly immediately, an answer or something. You need to say something to them, and you shouldn't do that. You should think about what questions to ask them to get them to talk as much as possible. That's extremely important. It keeps you from running into solution mode too soon.
Super important.
Which has a tendency to back yourself into a corner. And you've now made a tacit commitment to something that might not be a good idea in the first place. It might not even be a valuable problem. So take it slowly and have great respect for the first moments of understanding a new brief. So you get a brief from someone, you go in and investigate. Be cool about it. Be calm about it. It'll work itself out. If there is something there,
Yes,
it will be found.
no, but I agree with you. You have to, again, you have to gather the information. If you go in there and say, listen, okay, we're going to do a deep learning model and we're going to be building this system for you, and we're going to start, and then later on you're like, wait, why did I commit to this? Why is this is not the right solution? All I need is a simple regression, linear regression. It'll solve your problem beautifully. Why did I say this? Or like, whatever the context may be. No, I 100% agree. You mentioned there's different kinds of tools that you use in order to not paint yourself in a corner. One of them is asking questions.
Yeah.
Is there anything else you also use in that context or scenario that you think might be useful?
Yeah, pause. So when I've left the client, I take a lot of mental breaks while I'm thinking about the problem, and I force myself to backtrack and stop, and give myself very, very specific time to think about something in a concerted effort to give it the attention it deserves. So what do I mean by this? So it's like, think of, writing a physics exam. You read the question and you start solving immediately because you're looking at the watch, right? When you've read the problem formula or the exercise or the problem on the exam, stop, think it over again. Force yourself to think it over again. Force yourself to repeat the problem to yourself. Listen to what you say. Take those seconds to think about it before you start rushing and falling in. I keep myself from falling into things too quickly, consciously, because I have that tendency to want to deliver a solution. It's that passion arises and you want to get the data and train the model, everything in one day, and then you spend your whole night, making it work, and it is a very, it's not only unproductive in the long run, but it also tends to generate the wrong kind of answers.
So I saw that glint of was a satisfaction. That when it's a difficult problem and then when you solve it and you build something and it's kind of looks like it's working and you think it's working, it's like that level of that feedback that you get from it. It's almost addictive in some way.
For sure. It's a tangible feeling when you code something or when you're working on maths for something and you tie it together and you're done. And it's going to work, or you've tested it and you see it looks like it's going to work. There is a tangible dopamine effect from that.
100%.
Yeah.
Okay, so flipping a little bit the direction, what do you think is your biggest, or your like, I guess the top 3 most proud wins that you have gathered to date?
Okay, the top personal victory, if you will, in modeling is the lay-by intervention model, which is generating a lot of revenue savings in terms of reminding the right people at the right time to finalize their laybys and to make payments towards their layby. So that's been a great success, and there's some very big learnings for me building that thing as well, learning how to combine response modeling with the value of the response and using that to guide the process to kind of run itself. So it's a halfway, almost reinforcement learning situation, not quite fully, but there is a feedback loop in terms of the model generating its own data, which is very cool. That's, I guess, number one. Then a couple of years ago, we finished up a project about logistics A/B costing, which was a hard problem to solve because of the complexity of the outbound logistics network. But we We managed a very small team. It was myself together with Greg Giannopoulos from PKL. We came up with the way that thing needed to be solved, and we had some help, obviously, from you guys in putting the solution into production and making it into a new billing system for PKL. So that solved a lot of problems. And actually, as late as today, I heard that it made a big impact on one of our subsidiaries when they negotiated price with a transporter, and they are saving a lot of money using that data.
That clear information, clear data, so they could just be like, listen, this is what we're going to do. And
this is
how
what
we're
it
gonna
costs. And it's extremely hard to argue with that model because it's so
Exactly.
granular. It divides the journey from DC to store into 10 steps, and every single step of every single parcel is costed down to the cent. And every cent spent in the network is accounted for by the model. So it matches up with your books exactly down to the cent.
Yes.
And that's how it's built to do that. But the way it had to be done was quite a tricky exercise, which we cracked. One of the top executives in the business said he's been trying to find a solution to that problem internationally, looking internationally as well, for 15 years of his life. And we did it. So that was...
Oh, that's a nice win.
Yeah, it was a cool win.
That's a nice win.
The third one, I think, would be the current project. So it's not delivered yet, but we're running a very cool project in advanced analytics and optimization for the group. We got multiple brands on that project, potentially up to 6-7 brands are jumping on. We'll see. It's still, some of them are still deciding. And we're running it as a big analytics team or a big agile team. And that has been an unbelievably cool experience to see how people liven up when they work together with others on the same problem and same issue. And 4 different types of people are in there. So you got your data engineers, data scientists, machine learning engineers, more the pipeline, people, and then you got software engineers, and all of them are working together. And I'm in the middle of that thing, spewing out demands and ideas, and it's just an absolutely beautiful experience to see the efficiency difference when you work like that.
Yes.
As opposed to when you work 1 or 2 people on a project, or sometimes one person does 2 projects. So, and that's also a huge learning for me personally. So how these things can be done, it's still not been discovered what's the optimum way, but this is definitely better than what we were doing before. So I'm enjoying that very much. And the big win is in the fact that we've managed to get that many brands to sign up.
Yes.
For the same solution.
Yes. Yes. I think for context there, that's a big thing in a big conglomerate. It's like you have different entities who's like thinking of, they're locally focused on how do I solve my problems and how do I deliver on my KPIs and how do I get my revenue up. But then there's problems that affects all of them, and there's a solution that can affect all of them. Like you said, then when all of them actually sign up and participate is when you're able to, across the whole board, make a massive impact.
Yeah, each selling job is a big job in this space. Anyone who works in this area knows how hard it is to convince a big business to jump onto a advanced analytics solution. First of all, it's not cheap. Mm-hmm. Secondly, it's complex, hard to understand. Then it's that big data question, do we have all the data? Is it in the right format? Who's going to do all the engineering for this thing? Is it going to feed back into our systems properly? There's many questions before you get the go-ahead. And to make it happen for that many at once is, that's a nice feather in the hat, I think.
Nice. I actually want to... Okay, so the lay-by intervention one, that was one, that's your biggest win. And to me, it sounded like there's a few reasons for that. 1, there's complexity involved. 2, there's multiple uses of models and various clever applications thereof, is what I heard. And then the impact on the business is just big. So you've got both big value add, nice complexity, and great, I guess, technical solutions put together. Yes, that sounds like a dream project.
Yeah. Just took way too long to do it. I mean,
so one, that's always the case, and second, I understand.
Yeah. I mean, we would have done it much faster now, but hey, you got to start somewhere and learn how to do these things.
Yeah, I actually, one of the things I like to think about there is, one, there's always a lot of optimism when it comes to obviously timing and the delivery, but then there's also misunderstanding or not properly understanding some of the systems, and then there's also maturity of the system. So say, for example, you say, listen, let's get started today with a new logistics optimization system. And then it's like, oh, wait a second, 100 data sources have not been properly productionized. Damn, that's going to take a while we get started. And no, 100%, that makes a lot of sense. During your experience in this role and being lead data scientist and being a data scientist in a big retailer, what were some of your biggest challenges?
Oh, wow. So it's varied in a way. I mean, one of the challenges that you always will face is to convince someone that you can solve their problem. And perhaps more often than not, it gets hard because you might not actually understand the problem properly. So that is a big challenge, to get the airtime with the right people around things that may have an answer in data science. That's a big challenge. I think it's an expensive exercise to build a good solution. So it's a challenge to get over that hurdle of spending the money to do it. Sometimes it's also a gutsy decision to take on a problem if you've never solved it before and you think you can, and everyone's committed, and this whole project takes off and there's a lot of people involved. The pressure can get quite intense. So you kind of need to learn to or teach yourself or talk to yourself and tell yourself that it's okay to fail. It will be okay. The day we fail on a big project is not going to be the end. It's in the nature of the business. To solve a problem is by definition, problematic.
I mean, otherwise it would have been solved.
Yeah.
That's the whole point, right?
Yeah.
So that when you say the pressure, it's like that. It is the pressure of failing. It's the pressure of potentially, because it's so risky, because it's unknown, because it's a big investment, because there's a whole team involved. You don't want to fail. Nobody wants this thing to not succeed. But then again, there could be things outside of your control that could be detrimental to the situation.
Yeah, I mean, you might not be smart enough. You might not have the right people.
I doubt, but
you might not have the computing power. You might not have the data. You might not have blah, blah, blah. So there are a number of failures in our history as well. And you just have to admit them as fast as you can. When you realize it's not going to work, then you must actually open your mouth and say something to the right people and just shut it down and not carry on pretending like everything is fine. And that'll generally keep you safe. I say generally because, you can't always predict what clients will say and what people will say if you fail. But hey, most of the time when I've admitted to not being able to do something or admitted to have done something wrong or stupid, it's had a lot of good with it as well. You build trust that way. But that being said, it is important for the ease of operations. As a data scientist, your operations become much easier if you've had one or two good successes with a really solid delivery and a really solid solution. It gets much easier to talk to people. They don't require you to prove every single thing you say. It comes with responsibility, and you choose how you play that game. But yeah, honesty goes. I think honesty is imperative as it, and not. You need to be a dreamer, and you need to be the one who thinks outside the box. But you also need to be a realist while you do that. And the only one who can determine that is yourself. You're the only one who knows whether your thoughts are logical or not. Sometimes. So, if you take something to the client and you're not sure that you got it all, figured out, and you're not sure it's even got a remote chance of working, then maybe you're taking a risk. I generally spend a lot of time thinking about the solution before I get back to the client and even, hint that we'll be able to do it. So that's a lot of alone time, and it's a lot of conversations with individuals about specific issues and asking people if the data is really there, if the data is in production, or if it's going to be a once-off, all those things that you need to have in your head before you stitch together an answer.
So yeah, I'm picking up also a lot of then obviously mass complexity, not wanting. There's when you mentioned honesty, when you mentioned the having a history of successes, what came to my mind as well was the trust, the ability to create trust in the fact that they don't have to question everything, or you don't have to justify everything that you're saying. So that makes it a lot smoother, and then it makes it easy for you to almost ask them to take a leap of faith in, look, it's unknown, you don't understand it, you don't know if you're going to get what you need to get. I'm trying to assure you, but we've thought through this. There are risks. Nobody's going to lie about the fact that this could not go the way we intended to go. But hey, here's what we're going to do. Here's how we want to achieve this. And this is the goal and the vision. So take that leap of faith with me. So that approach, trying to get that right.
And a lot of these projects, you might want to, say that if you think about it, here's a difficult problem. Let's build the client a POC. Okay. What does that really mean in a data science context? Are you going to sort of half solve the problem? What does a POC mean in data science?
Sorry, half solve a problem. That's a great question.
You got to crack the nut. Even if you deliver something on a small fraction of their data, on a small fraction of their business, you have to still solve the whole problem. Yes. There's no escaping the chain of reasoning that needs to flow from the problem back to the solution. You got to have all those bits, and they have to be solid. And once you have that in place, what you've really proven is that you can deliver something, but you still have to solve the whole problem. So POC is not that much cheaper than an MVP, which would be a product that they could actually use and make some money out of.
I understand.
So we always go for the MVP. We will do a POC as such, if you want to look at it that way, by tackling one brand first and not all of the brands in one.
Makes sense. You can do MVP for everyone, but
yeah.
But talk about POCs, proof of in essence that they're most looking for proof of concept. And as you're mentioning, you can't just. It's not like I don't know where in which world you can just build a. I don't know. The only thing I can think of right now is like if you want to build a website, the proof of concept, I'll build just little pieces of paper and put it down in front of you and say, okay, well, if this and this happened, this is very cheap kind of little prototype just to see if you understand and reducing the risk, I guess, in that way. But that's it. Like what you're saying is, you can't do that in this world. You need the data. Okay, cool. But once you have the data and now you need to understand the data, now you need to model it, now you need to solve it. Now you've done a whole thing. And so it's going to cost you.
You've actually solved the problem. And you might look at it as semantics, whether we call it an MVP or a POC. That can also be argued. Are they the same thing? But if you want to kind of like put it in context, the POC to me is can you prove something with a minimal effort?
Can you prove something with a minimal effort?
Yeah. Like so not spend millions on something that and then it's often a very small step from what we would look at as a cheap POC to give them something that'll actually help them properly, which is a MVP, they can use, and they don't have to do much more if they don't want to. But then the full-fledged product would be a scalable solution that is easy to bring in other brands or other users. It's got optimized parameterization of all the differences between different users.
All the data sets
everything is
covered.
carefully designed and thought through. It's not just quickly put together in a pipeline that gives an answer. It's got more bells and whistles. It looks better.
It's got testing.
Easier. Yeah, it's easier to use. And often much more expensive to build, but not that much more expensive.
Understand.
So POC is cool. If you have a very big vision for what you want to do in the future, then your POC would be an MVP for your first brand. A POC, as in a non-usable product that proves something, is a nothing burger, I think, most of the time in data science or proper data science driven solutions.
I don't know where you got the nothing burger, but that's definitely
it's
a phrase
a movie
I like.
expression, I guess.
We have to look at this reference. It's a great reference, nothing burger. Yeah, okay. So maybe just to recap some of the challenges, it was obviously understanding the user, the challenge of getting users' trust, the challenge of the pressure that you have to deal with, especially in your role as being a lead and being the person essentially responsible for delivering this. And you also now the one who has been dealing with a client and essentially putting your neck on the block. You know, you're sticking your neck out. That's what I'm actually getting to. You're sticking your neck out in terms of being the face of this project, and then the pressure that comes with it.
Yeah, and recognizing that the business party, they also do that on their side, because they often have to drive a business use case inside their business to get the funding to pay for your project. So you're kind of walking with the developers in the business hand in hand throughout the project, and you become a collaborative team. You have the same objective. You want to deliver a valuable solution. They don't know how to build it, but they understand the problem. And you have to eventually meet their needs. And you have to figure that out. And that's the challenge. And while you do that, you also have to crack the issue or problem, or how do you build a solution for this? What does that solution look like?
All that technical complexity.
All the technical stuff. And then in that space, you need the freedom to think. So now you're under pressure, but you also need to be able to think at the same time.
How do you deal with this? Actually, maybe that's the next question.
It's a very tough problem. So you must do it actively. You must learn enough about yourself in order to be able to switch on and switch off certain aspects of your life. You have to be able to take the pressure off yourself. And it's in how you talk to yourself, and it's how you live your life. It's how you find the time to push every single thing that matters in your life, push it away for a moment. And for enough time to give you space to think, and trust that that time, combined with your skills and your experience and your colleagues that you can talk to, and books that you might read or websites you might want to go and check out, that time will get you there. And when you trust that process, then you can sign on to these projects and actually survive the experience. But there is no excuse for skills. You cannot do this profession if you don't understand the methods. How do you create a design when you don't know how to draw? How do you architect? How do you do an architecture? How do you build an architecture for a bridge or a house if you don't understand house building or bridge building?
How do you compete in the F1 if you've never even done a go-kart race?
Yeah, you have to have the skills, and you have to understand the detail of a lot of different methodologies. And it's not just the different models. It's not just neural networks and deep neural networks and XGBoost and light GBMs and all that stuff, and regression and whatever. It's not just the predictive models. If you want to come up with a proper decision support solution, you have to understand optimization. You have to understand linear programming, mixed integer programming, mathematical programming, and discrete optimization in general. You have to have a basic understanding of what that is and how it works. You might even need to know what stochastic programming is to be able to think properly about some of the problems out there. Then, as a data scientist, you should have a basic understanding of machine learning operations and what's required of you as a team member in terms of that space. What is a pipeline? Why does it need to run the way it does? Why do we need all these things that look like admin? And what will happen if we don't have that? Then you need to also eventually understand what data engineering is all about and how you build a proper data lake, or to use a modern and cool expression, lake house. Put some order in the data lake, and that makes it easier to use. How is that done best? And in your environment, what will it look like? Nobody from the outside can tell you exactly what you need. You need to be there to work with the designers of the data layers. How your naming conventions work, why you do certain things the way you do, why do you separate the source data into client projects? Well, so you can bill for the data usage, stuff like that. Everything becomes a very big, complex picture that if you don't understand it, you're going to make so many mistakes when you think about the solution that you won't get anywhere. So, and I love military history. I read a lot about old wars, and it teaches you something about leadership and the requirement on a leader that we sometimes forget. We think it's a generic skill, but a leader may not function as well in a slightly different area than they came out of. So, for example, a land general will not be able to guide 25 wooden ships in a naval battle because they have no idea how the ships actually operate. They understand what a sail is and a gun and a rudder, but they don't know all the intricacies of operating a ship and what it can do at the limits. How close to the wind can you actually sail with a wooden ship? Those things that determine your region of operability during the battle. So only a naval admiral will be able to guide the fleet through a battle. So someone like Nelson, for instance. If you put a hyper-intelligent general in that environment from land, like Napoleon, he would fail. He would have no chance because he doesn't understand enough about the detail of the environment in which he operates.
I didn't know that that's actually like a thing from the war. Like, you wouldn't have.
There's so many examples of it.
And a land officer.
From the early days of the war at sea in the Age of Sail, they actually used to take land generals and put them in charge of the fleets. They would do well in a very, very bland situation. They know all the leadership stuff.
I mean, they can order people
tough,
around.
They're brave and tough and all that.
Yeah.
But once things start to move and the enemy does something, what are they going to do about it? And what is naval strategy compared to land strategy? There's similarities, but it's too hard to make the leap of thought that quickly, as quickly.
Unless, of course, you were a land, let's say, general that has then spent 10 years on a naval, on a ship, but probably not as a general, but more as somebody helping. I don't know, with the lieutenant or the lower.
And we might discover this in our own space. We might, for example, experience the leadership from a very good software engineer. And we might think, or be tempted to think, that they can now lead the data science project because they're such a good leader and mature individual, very intelligent, well-spoken, and you put them in that environment, it may or may not work at all.
That's interesting. Yeah, but that's true as well, because they might not have the skills, they might not have the context, they might not have the, well, they definitely won't have the experience in that sense. Fascinating.
Yeah, and they lack a lot of the perception that you need of what's going on, the understanding of the current situation.
I might throw in there that in some cases some guys would be able, I would say there's a minority that might be able to survive and figure things out and think on their feet and change, and maybe
if they have a strong team, they can rely on the team. But often a really good strategy lives in one person's mind. The really powerful strategies are conceived in a coherent single space, which is one human being's brain, that can juggle all the detail, that can consider all the scenarios in one very efficient environment, which is our brain. It's not always, I believe, a must that it happens in one single head. Certainly elements of the strategy can be changed and debated, and that's a natural thing that needs to happen in real life. Your strategy has to change. But the truly ingenious, kind of leaps in human history have often just come from a single brain. It's a lot of, input, and we're building on each other, and I'm not taking anything away from that. But those ingenious shifts and paradigm shifts of how we do things, many of those things, click in someone's individual brain.
Through all the experiences and knowledge gained and everything. And grappling with problems, I guess, that needs to be solved. How do you identify or find worthwhile projects for the data scientists to work on inside of the organization?
Yeah, so I try to keep my attention geared towards the right spaces in business where conversations happen and where discussions are going along the interesting lines. So I keep up with certain individuals who I know think progressively.
That's clever.
Yeah, that's one trick of the book. I mean, I don't have infinite amounts of time to do this. But I ask the right people questions and see where they're going. And
I'm going to almost summarize that as you had that whole journey in the beginning of talking to a lot of people. So in other words, you could have identified individuals who have the ability to come up with interesting ideas or are in interesting positions that they can come up with problems, and obviously planting those seeds and letting them know, listen, come talk to me. And then also catching up and digging and finding, and then you'll find interesting problems, and then you can start developing them and then solving them.
And while that's true, it's also extremely important to always be open.
I see, I understand.
So I really try to keep an open mind, and I try not to push my solutions around in the space. I try to talk about problems and listen to people's. No matter how insane it might sound at first, there might be something in what they're saying that is really, really valuable. And it doesn't have to come from the top. Sometimes it's very much from the grassroots level. Someone says something and you think about it and you realize that maybe this is something we could at least evaluate and dig a bit deeper. And
this is an interesting problem to work on.
And then I try to go for the money immediately. How much is that potentially?
How big is that pay?
How big is that payday?
Nice. What is your methodology when it comes to dealing and working with data scientists? Or maybe let's not just data scientists, like any data specialist, maybe make it a little bit broader, like data teams.
Yeah, so I took goals with them. I described the problem. I tried to get them as much context as possible. This is the thing we're working on. I explain the problem. I might mention the aims that we've come up with early on in the proposal stage, where we say we're going to build a machine learning model for this. We're going to ingest source data for this. We're going to do an optimization model here. So I explain the idea. And I look for that moment when you can tell that someone is on board with what you're saying. So I give them some time. You know, I try to make it very certain to myself. I try to ensure that they've understood the problem. So it's really important that you give people time to understand what you're talking about. I hate giving somebody a task that's isolated and boxed in and has an input and an output, and then ask them how long it's going to take. Because at the end of the day, you want to engage them in the project. You want to get everybody engaged and think and help you cover your bases.
Sounds like ownership also.
Yeah.
That's really nice.
So rather than creating a organization where you now dictate the tasks on a regular basis, I try to create a space where these people are basically operating in a bit of a fog of war for me, but I can at any point in time, I can see what goal they're working towards. So a goal could be a 3-week achievement, for instance. You could say, for instance, I want to see a feature store with some really good features at the end of the sprint. And then they know exactly what to do. And I don't check their ideation. I'm there,
in case
available.
You need me, in case something goes wrong, in case you need some insights on block or you need to bounce something, you're here. But if you're going to do your own thing, I'm going to trust you're going to be able to execute on that.
And I don't criticize the output. I almost never criticize the output.
That's an interesting point.
But I might criticize the effort.
That's a good point, actually.
It's very important to know the difference here. There's many good movies about this concept. And it's also something I apply in my personal life with my kids. Effort is something you can control unless you get sick. Sometimes you ask somebody to solve a problem for you. And to think about what the client needs in the right way, that is a very difficult thing to nail down and say, I want this output here. You'll know when you see it if it's going to solve the problem or not. Most of the time anyway. You'll be able to understand whether this thing that's being proposed is going to address the issue. But how do you predict whether that's easy or hard or how long it's going to take or any of that? So if you venture in as a leader, if you venture into the territory of punishing people by criticizing their work, if you're not happy with the work and you think that that's going to make them produce better results, you better be very, very good at predicting how long things take, what quality you can expect. And for anyone who's worked in this environment,
nobody's going to want to work in that environment.
Yeah, no, because it's outside of the individual's control. Output in our space is a wildly varying variable. Sometimes it's great, and sometimes it's nothing.
Because a problem can be super easy, a few lines of code, this, that, put it into an XGBoost, winning, or it could be months of iteration and trying and testing different theories.
Managing people here in this space is more about much less managing them and much more looking after them and being there and setting goals together with them, deciding together what's a reasonable goal for a 3-week period. That's easier than deciding exactly what this person is going to be doing for the whole duration in 10 parts. Set one goal that makes sense. Be ready to accept that might not have been achieved. And look at whether the person tried hard enough. What did they do to try? You can help them moderate the effort. For next time, they might not want to go and read on Kaggle the whole time. They might actually want to pick up a scientific paper, or they might want to go and talk to the client.
Unblocking them, finding a different way to get information, helping direct them, and look, you spend too much time understanding this model. You could have used these models, or whatever the case may be.
And it's also fine to have an environment where you can tell each other your output wasn't great. this is not good enough. There shouldn't be anything wrong in saying, I can't use this thing that you've given me. We need to try again. Tell me what you did to get here. Let me see if I can come up with a different way for you to approach this problem. Or go and talk to that guy who's done this before. They have a different way of doing it. Now you've tried your way. Go see how that other guy did it. And be very open about these things. And I mean, do it with sensitivity. So, I mean,
EQ.
with EQ, and don't criticize people in public for something you could have talked to them about on the side, if you suspect that this might be a touchy thing.
100%. Well, how do you measure success?
For myself.
In life.
In life.
And then maybe in projects as well.
Success to me is, you got to start with your value. So I think what I value, and I can't help valuing, is when I get to give something that only I can give in that moment. If I manage to do that, that's success to me. Success to me is not what I drive around in so much, but it's a function of giving as well. So it's being able to give from your talents or give from your abilities to other people is, I think, the best thing in life. Because it's worth something to the other person and you can muse about it,
And how would you define a success in a project?
Yeah, that's a smiling client, and with a good smile, not with the wrong kind of smile, and it's when the project is being spoken of by people, recognized, it's been seen for its contribution and not for the marketing we've done around the project. When it gets talked about, when something you do becomes the talk of the town for a little while, that's
a big success.
Yeah, and
it's such an impact that people spread it around and talk about it.
Yeah, I think so. And obviously, when you can see a big rand value to the project, then that's often enough as well. Then you might not even need people to talk about it, although that's very nice.
What do you believe are kind of the most important things to talk about when it comes to the current industry, like data science industry, data as industry, AI? I know there's a lot of hype around a lot of different things, but what do you believe are the more important things we should be talking about?
Yeah, I think that there's healthy competition in the space. There's a lot of interest in the area, and there's great belief that it can generate huge efficiency gains and huge benefits, positive new things, and that AI can help us in our lives. But I think what we need to remember is, as humans on this planet, our goal to increase economic growth has to be debated. How do we re-gear our society and our world to look at other objectives and not just economic growth, not just, more GDP per capita? So we have to stop doing that. I think we must start to value equality, and not just gender equality, but equality between people from different backgrounds in general, and measure that more prominently and chase that more prominently, and somehow build it into the life of our corporations, that they have to care about it, just like we have tried or have started doing with some of the environmental and sustainability type of laws that are coming in Europe and also might be coming here quite soon, where you literally have an adjustment to your share price depending on your sustainability index.
100%.
So I think there's a lot we can do as a human race. I'm not too excited about what AI can do for us. We have enough. There's things obviously that AI can do. It helps in medicine. we can use it for good. We can use it to be more efficient and keep our lifestyles going, but do so with less energy expenditure. We can do so with shorter supply chains, perhaps.
It's an efficiency and reducing waste, and they're creating a bit of more sustainability around being more clever about how things are executed. Because with the AI that we build and are used to, it's more about optimizing. It's more about just basically that.
Yeah, and that is helpful to humanity. I mean, this is probably controversial to a lot of listeners, but I always had a bit of an aversion towards marketing and pushing people into, using their money for stuff they don't actually need. And I think when we employ AI to do that, to sell more things,
manipulate to sell more.
That's an interesting area where you could argue that, well, if I put an offer in front of somebody and I hit them, it's because they actually wanted it in the first place, and I just made it available, or raised their attention towards the fact that we can offer it. But yeah, sure, that happens. But morally speaking, you're walking an interesting line.
Interesting one. Is there any advice you would like to give a up-and-coming data scientist who'd love to one day be a lead data scientist within an organization?
I think as a aspiring data scientist, whether you're young or old, but aspiring, you might have moved from one area into data science and you want to be successful, I think learning to listen is your first job. Learning to understand, or listening to understand. Stop thinking too much about what programming language you're going to use. Don't worry so much about modeling techniques or modeling algorithms. What you can do with a random forest, you can do with the XGBoost, and you can do with a light GBM. The key to success is framing the problem, solution, and then only putting it in place. First, framing the problem properly. Decide very carefully what you are going to do for the user. Interrogate the user. Ask them, what exactly are you going to do? Literally, what are you going to do when I give you the predictions? What are you going to do with that? Where does that feed into your life? What does your process look like after I've given you my solution data, my answer, my prediction? Tell me about your process. Ask these questions to the client. Learn how to ask them, but also learn how to listen. Then on the other side of the coin, in your left-hand brain, understand modeling deeply. What is modeling? What is predictive modeling? What are these models capable of doing? Interrogate the outputs like you found a giant gemstone and you want to understand every single aspect of it. I used to tell my students in regression modeling, once we've fitted a model on this tiny data set that we used to use, or all the data sets were tiny back then, I used to tell them, now you have your $1 million thing. We've fitted the model. Here's the thing you paid money for. You paid money to run an experiment. Now you've trained this, or fitted. We didn't say train back then. You fitted the regression model. That model is the answer to all of everybody's questions around this piece of equipment you've been testing. It's worth money. Now look at it. So we went into this whole next level diagnostics of the model to interrogate that model and see what it is actually capable of doing. These days, machine learning specialists and data scientists, they look at one metric. Their biggest question is, should I use the root mean square error? Should I use, for classification model, should I use accuracy? Or should I use a Gini curve? It shouldn't end there, folks. You need to go and see how that model performs on your data in detail. You need to look at the residuals. You need to look at how they behave. You need to check whether your model is equally good over here and then it is over here in your data. How does it behave against the different features? How does it behave against the predicted values? Go and look at an old stats book and see what diagnostics they run on a regression model. Why aren't we doing it on machine learning models? I don't know how many times I've found data problems in our own pipelines using proper machine learning models by looking at the residual plots. That is a piece of advice I can give, technical advice. Interrogate your model, understand it. Don't just train it and drop it somewhere and deploy it.
I can almost see you screaming, this is a 100 million rand model.
Yeah.
It's affecting the business. Why would you not spend time just to really understand what's going on here?
Exactly. And then you can start to understand, what does root mean square actually mean? Is it just a number? No, it isn't. It has a meaning. That's one of the metrics that has a very, very applicable meaning. So go and understand those bits. Learn how to train a model. Learn how to work out complex features. Understand time-related features, those things. This is where your brain is needed and no one else can help. The business person is not going to do that for you. They won't be able to. They can't write complex SQL queries. You got to do that. Who's going to train the model using the right setup, with the right parameter tuning, with the right feature selection methods, those things. Those are the powerful parts of a data scientist's arsenal that can really drastically increase the accuracy of the model. Very good feature engineering, but think, what is the connection? Think about, what is the connection between my features and the predicted response? What does this model actually do inside? Go and understand the tree models, how they're built. Go and think of your own explanation as to why XGBoost might be a more stable approach than just doing a single regression tree on your data. Why is that so? Understand why that's the case. When you get a deeper understanding of what modeling really is, and forget about the Python versus R conversation and the packages you use, and whether you should plot using Plotly or Seaborn or whatever. You're needed in the thinking space, and you're needed in the understanding the model phase. No one else is going to do that. So remember, your purpose as a data scientist is to provide a good and trustworthy model, and to be able to show how you got there. And in the background, you need to understand what's going on.
100%.
So don't just go to Stack Overflow and pick a script now and copy paste, and that's your solution, give it to a client.
Oh my goodness.
That's very risky.
Jonas, I would like to say thank you so much. Thank you for coming through today, and thank you for having this conversation. I think there's a ton of interesting gems here that we've spoken about today, and I really enjoyed it. I actually really think we should have another one at some point in time, because I think there's a lot of stuff we could probably still further explore and go into, and maybe even get a bit more technical. I don't know. We'll see where it goes. But yeah, thank you so much for being here.
Thanks, Pierre. I enjoyed it very much. Very good questions.